Hello, everyone. Good morning, good evening, wherever you are. My name is Julian Donchev. I'm a product manager from the Oracle Group. I'm along with my colleagues, JP and Matt. And the presentation today is on a topic which is very much popular, up to date, and hot at the moment. It is how to migrate MongoDB to Oracle. We have from our migration team, Matt DeMarco, who is going to give the major presentation and who is going also to show you some demos. He will show you how you can migrate MongoDB to Oracle, which in fact is quite easy, simple. And all the details are over to Matt, and JP and I will be trying to answer a question in the live chat if there are any questions. So over to you, Matt.
Excellent. Thanks, Julian. And yeah, like Julian said, good morning, good afternoon, good evening to our audience members. My name is Matt DeMarco. I am a product manager inside the Oracle's platform migration group. We'll get into my titles here in a second, but just real quick, just safe harbor statement. We'll be showing some things here that are forward-looking tools that we're developing, approaches that we're developing. So just be aware some of the things that you'll see are part of our research and development, as well as to the pathway of developing actual product. But like Julian said, today's speakers are going to be Julian, JP, as well as myself. So like I mentioned, I'm a senior principal product manager in our platform migrations group inside of here at Oracle. So we work in the database organization to develop processes, products, programs for helping our customers migrate from non-Oracle databases to Oracle. So my team covers a wide variety of sources from anywhere from mainframe, IMS type of implementations to Postgres, to Snowflake, to MongoDB, SQL Server, Sybase, etc. So we cover a wide variety of sources, but the single target that we put forth is that everything goes into the Oracle database. And so for our agenda this morning or today, it's a very simple agenda, but like with most things, it's embedded complexity that's in there. So we'll do a very quick architectural overview, talk about the proposed solution, why we believe the Oracle database is a superior implementation for a vast array of data platform needs. We'll talk about the migration process, and then we'll actually do a migration demo. So we'll walk through each phase of this migration process that we put forward and show you how this process feeds one stage, feeds the next stage, right? So with that, we'll move into the architecture overview. So I'm sure everyone's heard about the Oracle Converged Database. If you haven't, basically what we propose here at Oracle is that don't implement an additional database, just use the associated data type. So Oracle has had multi-model, multi-workload support for years, most traditionally with relational-based workloads and analytical-based workloads. Right? So, but if you look at this list here, you'll see that we've, over the years, expanded into more data types, supporting more workload. So we introduced support for XML, I believe, in 9i. We introduced formal JSON data type, I believe, in 19c. Correct me if I'm wrong on that one, Julian or JP. And then, so we've also had supported Oracle text. This is just, search essentially for data inside the database, free-form text since I think 817. So it was also known as Oracle Context back then, or the text cartridge. And then we've had support for graph inside the database for quite some time as a natural extension to our spatial implementation. And then that forms into spatial. So if you need to do any sort of advanced geographic information system type workload with a degree of fidelity for the curvature of the Earth, things like that, our spatial engine takes advantage of that and is aware of all that. You can have different datums, you can have different origination points and things like that for your measurement. That's all in the spatial engine. Like I mentioned, analytics, we've had support for star schema, snowflake schema for years. One of the most groundbreaking innovations that we did years ago was introduce the in-memory column store. So this basically allows us to use SIMD vectorization to actually create columns, organize data in columns as opposed to a heaped row store. So this allows us to do very, very fast analytics across lots of data. So you can consider an average. You're looking down the column. We do that all in memory. And then we introduce support for blockchain for immutable data with attribution. And then we've had support for machine learning inside the database for years. I think, again, since 8.17, maybe a little after that, maybe 9.9. So if you need to do k-means clustering, support vector machines, somewhat unsupervised machine learning, that's all baked into the database. We also support R inside the database. So R is an open source alternative to SAS for advanced machine learning type of approaches. So if you have a data scientist cohort, you can leverage R, you can leverage the database machine learning capabilities that we have. And then most recently, we introduced support for vectors as part of our support for retrieval augmented generation, RAG-based workloads within inside the database. So if you do SIMD, or excuse me, cosine similarity searches and things like that, leveraging vectors, that's all baked into the database. And the reason I bring this slide up is just so everyone understands that, right, as opposed to implementing a vector database, and we've heard about this probably about 2 years ago when LLMs and generative AI became relatively hot, is that everyone started looking at a vector database to have support for this RAG-based workloads. Well, you don't really need to do that with Oracle. You've already invested in Oracle. You can just implement this new specific data type inside the database. I think that's enough on the converged database. But for the architecture of what we're discussing today, we have this implementation called the Oracle Database API for MongoDB. And it's a relatively straightforward implementation of a Mongo wire protocol listener. So what you'll see here on the left-hand side is the Oracle Database 23AI. And the reason I have 23AI here specifically is because we've introduced additional features inside of 23AI for aggregation pipelines, multi-value indexing, things like that, that make it a very easy migration target relative to older versions of the Oracle database. But you could still use 19C if you wanted to, but we prefer and we recommend to our customers 23AI. And then in this architecture, we have in the middle here, Oracle REST Data Services, or ORDS, ORDS. So ORDS is basically just this piece of middleware that acts as the Mongo endpoint listener. So what will happen is the tools on the right-hand side of this slide are your user applications, your applications, tools, frameworks, etc., that are all speaking Mongo wire protocol. They're not speaking Oracle. They're not speaking SQLnet. All these tools are connecting up to the ORD server over the Mongo port that you define. Typically, it's 27017. And so we take that, ORDS take that, transcodes it into SQL, and it executes SQL on the back end of the Oracle database. And so this architecture is the same, ostensibly in OCI with the autonomous JSON database, or if you're using autonomous transaction processing, you can enable this as well. And so this architecture is the same as well as it would be on premise as well. In OCI, using autonomous JSON, this is all just handled for you. It's all managed by the service. Whereas if you implement this on premise, this goes into managing that software stack on premise as well. And as we move forward on our architecture overview, we'll just real quickly touch on a little bit of a JSON primer. I don't like to assume that the audience is fully aware of JSON. So, and this should look familiar if you're familiar with just implementations of relational databases, tables, tuples, etc. So the first and foremost thing is we have a document, and a document is just some JSON value or arrays or things like that with the data types that are in there. So you'll notice here on the right-hand side, you'll see that the document with the ID, object ID, name, Jeremy Jones, etc. And then from that as well, you'll have a collection. And a collection is just a group of documents. And so typically, these should be related some way. They should be, right, a collection of similar documents. They don't necessarily need to be. One of the reasons people choose JSON for highly mutable DevOps type of workloads is because they don't really have to have a hard and fast data model designed from the beginning. They can iterate on the data model as they see fit. So you can continue adding additional attributes to the document, etc. But regardless, so a collection is just a group of documents. And then lastly, we have a database. And so the database is just a collection of collections or a group of collections, right? And so if you look at this and you map this to your Oracle knowledge, starting from the bottom up, right? A database in Mongo parlance would actually be a schema inside of Oracle. A collection would be a table, and then a document would be an individual row, right, or an individual tuple. So it maps very, very elegantly to an implementation inside the Oracle database. And so with that, we've introduced in 23 AI, right, Joel? I believe it was 23 AI. We introduced JSON collection tables. So JSON collection tables are just a special type of table. It's a table, but you basically just invoke create JSON collection table and you give it a name. And so what you'll see here is that this will actually create three columns for this table. The first column is the data column. This data column is going to contain your JSON data. And we have a specific implementation or a data type implementation of JSON in the Oracle database called OSON. It's tree encoded. It actually allows very quick updates. We don't have to actually access the entire document. We can actually navigate the tree to actually piecemeal up, do updates. And so we have that data column. And then there as well, we have a couple of invisible columns that are visible by default. We have res ID. This is our top level identifier, your ID, right? So if you can consider a JSON document or a document workload is just basically a key value store. The ID is the key where you can do just efficient access via the index. And so that res ID is created by default for you, and it is invisible, and it is a auto-generated column that creates an ID if you don't provide one to the database, right? It's very similar to like, the sequence data type, if you will, or is it sequence? I forget what the actual data type is. But and then lastly, we have E-tag or entity tags. Entity tags are there for optimistic concurrency control. So if you wanted to know if the data actually changed as you were, accessing the data, things like that, we can support entity tags or E-tags as part of this workload. So, right, if you wanted to handle concurrency yourself at the application tier, this is somewhat a way you can do it, or you can just let the database do it and use the ACID tendencies of the Oracle database, right? So what you'll see here on the right-hand side with this graphic is the create JSON collection table registrations, and then you use SQL to do info and shows you, exactly how the table is created and the associated index that's created with that as well on the res ID. But then we can also specify create JSON collection table with the E tag, with the entity tag. And so if you were just taking a look at the E tag in the prior graphic, the raw byte size, I think was 16, because we really aren't using the entity tag for anything in that default implementation. But if you need to use the entity tag, again, completely optional, you can specify that and you'll see that it's 2000 bytes to actually have that, and it's auto-calculated for you in that. And then lastly, one of the things that we can do as well is we can get really sophisticated by leveraging the Oracle database, and we can create this JSON collection table with the entity tag. But then what we can do as well is if we know the actual document, the content that's going to be in the document, the attributes that we want to actually access with any degree of frequency, we can actually create virtual columns of those, create virtual columns from those attributes inside of the document. So this provides us very fast, efficient SQL access to the JSON document. So you'll see right here, I have three virtual columns defined, name underscore VC, where I extract the name attribute from the document. You have email underscore VC, where I extract the email attribute out of the document as well. And then lastly, I do an email domain where I extract the email address. And then from that as well, I also grab the document, or excuse me, the domain of the email address, right? To do that. So you can kind of organize your table in a way that allows you very quick access. But what's also great about this is we can leverage Oracle partitioning, and we can partition by list, right? So we have our very partitioning types: range, composite, list, interval, I think is another one. And so we have those partition types, but we can also do partitioning by list. You'll notice here that I partition by the email domain, the virtual column, and then I do it in an automatic fashion. So I let the database create all my associated partitions for me. Before automatic partitioning, you actually had to create this and have an overflow partition defined, etc. So you'll see here that I partition by the p_oracle and where the values equal oracle.com, and then I can invoke some compression in there as well, and then as well enable row movement. So if I need to have data, if someone changes, like if a user changes their email address, I can actually flow that from one partition to another partition. I'll pause there if there's any questions, Julian, before we jump into the migration process.
We don't have any questions right now, Matt. You can continue.
Okay, great. So we'll jump into the migration process here. And one of the things that we like to put forth to our customers is this user journey. So we like to make sure that we have discrete goals and objectives for each individual phase. Because what we've observed is that in a migration, a lot of customers look at this as an opportunity to clean up old code, et cetera, optimize things. And that's a completely valid thing to do. But as part of the migration, what we want to do is just migrate the workload. And so if you're familiar about the R patterns of migrations or cloud migrations, you have rehost, replatform, refactor. And so if the migration journey is rehosting, right? You're hosting it on OCI with compute and you're just doing a self-managed type of implementation. That's a completely valid thing to do. Whereas you can get a higher return on investment by replatforming. And replatforming just basically allows you to use the platform as a service. So autonomous JSON database, the database manages everything for you. And that's a replatforming type of motion. So there may be some things that you might have to modify to work with inside of the managed service. And then the hardest one to do is the refactor or the re-architecture. These are synonymous.
Matt,
And
we got one
so,
question, by the way, if you can answer it.
yeah,
The
yeah,
question is how many partitions will be created? It refers to the example of list partitions.
that one previously, by default, we have just one partition. So just to kick off the partition creation, you have to give it one partition. And then after that, anytime in that specific example, anytime that you would get a new user who registers with a email address. So say, for example, myself and JP and Julian, we register and it's all our email addresses are, Julian@oracle.com, right? So Julian would fall into the Oracle partition. Well, we could conceptually have somebody that registers from like, GeoCities, right? And so, so we could have, Bob at GeoCities. And so when Bob registers, automatic partitioning will kick up. It'll create a partition for GeoCities, and then Bob's record would be in the GeoCities partition. So it is just completely dependent upon the logic that you have for the virtual column to do all the parsing of that and creation on all that. That makes sense, Julian?
Yes, of course. Thank you.
Of course, just want to make sure I'm making sense to everyone. And so for the migration journey, right? So we have these patterns, these R patterns, and with the MongoDB migration, this more or less falls into a replatforming type of journey, even though you're changing database engines behind the scenes, because we're leveraging that MongoDB API. You're essentially using the exact same code, the exact same frameworks, operators, et cetera, that you have in Mongo, but at the Oracle database. So the objectives for this migration phase is to achieve parity and get functional equivalence, right? So we want to make sure the system performs as well or has the exact same characteristics as the source system, as well as if we need to change anything. And so one of the things we want to do is we want to reduce the amount of code rewrites or introduction of additional code into the code base to achieve the same functional equivalence, but sometimes that's unavoidable. So we want to achieve that functional equivalence. So say, for example, we want to do that parsing of an email address into an email domain in a MongoDB environment that works with an aggregation pipeline to do a new projection of that, right? You access the document, you project out the new information that you want to have, and you materialize it to present it to your application. We can do the same thing inside of SQL as well if we don't support a certain operator. And we'll talk about what that is. And then in the optimization phase, this is where we really start focusing on increasing performance. And so what we do with increasing performance is we do a couple of different things. We would implement a sane partitioning strategy, right? So the partitioning strategy that I just showed was just an example. And so we would introduce a partitioning strategy that allows us to do maximum partition elimination for individual query, right? So if you're familiar with Oracle, again, the way the optimizer works is if you have partitions and you need to access the data in a specific partition, we can do partition elimination, which we don't query the partitions that are not of interest to the query. We could do that. So we could have a same partitioning strategy for that. Additionally, on top of that is we would introduce indexing, same-based indexing. And the indexing would allow itself to be, have each individual query to be a searchable query, right? Search argumentable. So this basically allows us to have a query that actually uses an index, because I think the difference between the two, right, a full table scan versus an index scan, full table scan I think is ON, whereas an index scan is O log N. So it's exponentially faster to do an index scan for your increasing performance. And then for increasing efficiencies, we work with customers to look at if they're in OCI and they're using elastic pools to actually have the service scale out, scale back as needed depending upon the workloads that they have. So you can actually increase the efficiencies. You don't have to have the largest instance shape to go ahead and support your workload. For those spiky workloads, you can just allow the system to scale up, scale down for those spiky workloads, so you can increase efficiency, so you maintain performance while actually having control on costs. And then lastly, for innovation, the goal here is to introduce net new capabilities. So again, if we want to migrate, we migrate this MongoDB workload, we introduce efficiencies with sane indexing, sane partitioning strategies. And now we have that all ironed out, and we want to move into introducing, say, a RAG-based implementation or vectors inside the database. This is where we start introducing those net new capabilities, how to add those features to our application with the same data management platform. And then with that as well, we can also look at having a converged data management platform. So now, just because you have the data inside of JSON data inside the Oracle database, given the duality nature of how Oracle accesses data, right, we make the same data available via a Mongo API call. The same data is also available via SQL, and so you can access it with this dual nature. So, even though you're consuming data with JSON documents, you can actually do reporting with, any standard BI type of tool against your database, taking advantage of the way Oracle just provides duality to the data for that. And so that's what we put forth. But to double click onto this migration process, so now we're in the migration phase. We put forth 4 discrete phases, not discrete, they somewhat bleed into each other. But we can apply technology to these phases. So we put forth planning. In the planning phase, this is where we do our goal definition, our stakeholder identification. So typically, when you work with my team, we'll have a questionnaire, and the questionnaire is there just to have alignment around what the workload is, how many collections are in the workload, is it on premise, is it hosted in some other cloud, what's the instance shape, what's the amount of RAM, CPU, et cetera, right? We have that as a questionnaire. So that kind of gets us aligned up for the goal definition on what we want to do. And then we have the stakeholder identification, which is important as well. These 2 things are more or less people skills, soft skills, where we want to make sure that the DBAs are aware, the Oracle DBAs are aware of what we're implementing, as well as the application owners as well, just in case we have to change anything. And then what we introduce as well is a workload assessment. So we can actually use some approaches to assess this workload to forecast any effort that you may have to do uh, for the workload. So, by and large, our observation is the classical trope of 80/20. 80% of the customers, I would say even further than that, higher than that, of customers, they migrate to the Oracle database API for MongoDB, and it works out of the box. There's nothing they really have to do in terms of changing the application. For those, less than 20%, we may have to do some changes in order to look at and forecast where those changes have to occur. We do this workload assessment. So we'll actually demonstrate the approach for that. Let's see if I can get the slide to move. Yep. And so we'll demonstrate that as part of the demo. And in the preparation, classically what we see, the preparation phase consume about 25% of the overall project time in total, right? For just getting everything set up, source and target set up, right? Are you going from on-premise to OCI or some other cloud, right? Is the networking set up? Do you have a landing zone? In the cloud, right? Do you have a same migration strategy? Identification of the migration strategy. Right? How big is the data that you need to move? What's the cutover definition, right? Do you have like a weekend? Do you have a couple minutes? Do you have a couple seconds? And given that, we implement different technologies for that migration strategy, and then we can actually just do prerequisite checks on this. I'll show a little script that I use with my customers to just make sure everything's set up correctly, right? Because that's, again, one of those things that consumes a lot of time, just making sure everything's set up, especially in the on-premise case. And then in the execution, traditionally, this is where a large majority, so I said that in the preparation phase, you have like 25% of effort of the entire project is there. In the execution phase, you probably have close to 50% classically, traditionally, because you have to, when you're changing database engines, you have to do database object migration, right? So say, for example, you're coming from Postgres to Oracle, and you want to have a degree of precision on a number data type, or an integer or a float. Just making sure that, right, if it was a big int in Postgres, you have a float as defined inside of Oracle to do all that correctly, right? So you have to do that. You have to change the actual object. You have to change the data type for the data platform. And then with that as well, the application code migration. So now you'd have to actually change the SQL from that Postgres case over to Oracle-based SQL. You can use ANSI SQL and things like that, but a majority of customers use very default specific implementations of their database. People do that, and then you do the data migration. The data migration, again, is depending upon the data requirements, cutover requirements. The data migration will differ, and the duration of the data migration will differ as well. So, for example, if you have the requirement to run these systems in parallel for, say, 3 months, just to make sure that you're doing quality checks of the data, fidelity checks, things like that, right? You'll have that. Or if you just want to go ahead and just do a very quick, we've seen some MongoDB applications that are, under 5 GB, where we can actually do this, very, very quickly, migrate this thing in a half hour and be done with it, right? So right. And so we'll show the data migration, an approach to data migration in the demo here, leveraging native Mongo tools. One of the things that I'll show is that we're actually not using a lot of Oracle libraries or Oracle tools for this migration process, because it actually acts as proof positive that the API is working correctly for that. And then lastly, testing and validation. And so we'll show a couple different approaches. We have some things in from product coming down the line on this, but right now what I do is I have a little custom script that I use to do all that, right? So in the migration process, in the preparation phase, what we want to do is we want to do some workload analysis. And so we want to profile the workload. And typically we have 3 types of approaches for doing this. And so application code review, is, you go through your application and you actually understand the pipelines involved, the operators involved, and you can map those things up to the supported matrix of operators and operations that Oracle supports, right? So this requires some in-depth knowledge of your application, some in-depth knowledge of the operations that it does, and then the associated way Oracle implements those as well, right? So for a lot of customers, they find this to be not not the easiest thing to do, and we also deal with some quote unquote legacy applications as well, where the team that's actually supporting this doesn't actually know, doesn't actually have like access to the actual source code. They actually just could change data connection string. And so doing that application code review is somewhat of a non-starter. So what we recommend for those customers is we recommend doing one of these two queries inside of MongoDB. So db.serverStatus basically will output a bunch of metrics from the MongoDB system. And the one thing we're looking for inside of this metric collection or metric document is we're looking for the operator counters. And so we'll just take a glance at that, and knowing the supported operators and operations that we do inside of Oracle, we can very quickly map that for our users. Or we can also use this MongoDB profiling, database profiling. And so the database profiling that we recommend for these workloads is a level 2, which captures like the exact operation against the namespace and gets all that. Right. And so that's what we would recommend for customers. The downside of that database profiler is there is associated overhead, whereas like the server status has no overhead. It's just a very quick query. The counters do reset every time you reboot the Mongo system. So you may not get all the data that you need occasionally, but the same thing falls in line for the database profiler as well. Again, like I mentioned, review the operations and operator support, and then review the support frameworks, right? Is your application running? Is it a MERN-based application? MERN stands for Mongo, Express, React, and Node, right? So what you're seeing here on the right-hand side of this graphic is a Node.js-based application that's running a pipeline. So you can see that pipeline is doing a projection, creating a new email domain in that type of workload that I was talking about. And then in the preparation phase, again, this is something that takes up a lot of time. If right, you want to make sure you understand your deployment target. Is your deployment target on premise, or is it in the cloud? Is it in OCI? So for the source system, you want to make sure that you have permissions to actually query the data, the collection, and that you have network access for this system. Now, you don't necessarily need to do that if you're just doing a bulk data export and a bulk data import. But if you're doing parallel CDC, change data capture, in any duration, you want to make sure that network access is set up. You have your firewall wall rules sorted and all that. And then for the target system, what you're seeing here is for the autonomous JSON database, you have to enable, there's a little switch. You have to enable the API. So you enable the API, and before you enable the API, you have to actually set up some ingress, egress rules to allow it to do that. So you set up those rules, then you turn on this little switch, and you're off to the races. Autonomous JSON database does everything for you. You don't have to worry about anything from that point on. Whereas if you're on premise, right, we have to confirm the database version. We have to confirm the database grants. We have to confirm that you have the right roles. We have to confirm that you have REST data services set up, and then also confirm that the API is working correctly. So not too hard, but there's work that needs to be done there to just sort all that out. And then lastly, the third step in the process is execution. So, as I mentioned, if there is an operator or an operation that we don't natively support using a Mongo type operation, like find one or things of that nature, we support that, but I'm just using that as an example. You can just use the SQL operator to just inject any arbitrary SQL inside of the Mongo application. So what you're seeing right here is just an example. This tool on the right-hand side is what's called MongoDB Compass. And so this is just the graphical user interface that Mongo provides for accessing a MongoDB system, either on-premise, Community Edition, Enterprise Edition, or Atlas. But you can leverage the exact same tool with the Oracle database API for MongoDB. And what you're seeing right here is we're using the SQL operator to do a standard, get the banner from $V version, right? And so this is actually executing a SQL statement from MongoDB shell against the Oracle database. So when we're really talking about the duality nature of things, and we're getting really, really fuzzy into like fifth dimensional type of physics here. So, and then once we have that, the application code layer all sorted out, we look at the data migration. So what we do with a majority of our customers, they just leverage the Mongo native tools. So MongoDB Compass has a facility where it can export and import JSON documents individually from each individual JSON document or collection, collection. But if you need to migrate a lot of collections, say hundreds and hundreds, I've worked with customers that have hundreds of collections, you can leverage additionally the MongoDB tools called Mongo Dump and Mongo Restore. These tools allow you to export the collection, the metadata associated with the collection, indexes, things like that, and then rehydrate those, leveraging Mongo Restore against the Oracle database. Additionally, if you're working with data that is the data scale is exceeds what you could actually put onto, like, say, an individual system or an NFS mount point. We have recently made Golden Gate for MongoDB migrations, 23 AI, free to use for 6 months. And so Golden Gate for MongoDB leverages our API. So you can do bulk export import using the exact same tools here, as well as we support change data capture with Golden Gate for that as well. So this is what it would look like inside of Golden Gate. You define your connections, you define a pipeline, and you're off to the races, leveraging Golden Gate. And then lastly, with the validation, we want to validate and cut over. So you want to confirm data correctness. So what you're seeing on the right-hand side is the application as it exists in MongoDB. And after the migration, this is the application as it exists inside of Oracle. Right? And so it should look exactly the same. There should be no perceivable difference. This is what we're talking about, the functional equivalence. If everything works correctly, right? Minimal disruption to our end users. Our end users are used to accessing the system in a certain way, look and feel of the system, things like that. And by and large, the majority of work that you have to do is you just have to update the application endpoint. So as opposed to, connecting it to your MongoDB system, you just update it with the associated switches that we require inside of the Oracle database to access the Oracle system. And then user acceptance testing, right? There are ways in which you can validate the data, checksum the data for correctness to get a degree of confidence that everything was migrated over correctly. But one of the things that we've seen continuously is that our users will actually do some kind of UAT with their end users to make sure that the application works the exact same way and the data is present as they require. So before I jump into the demo, any questions, Julian?
At the moment, we have no questions. We had one question which was answered by Herman in the chat.
Okay. Oh, Herman's here. Perfect. All right. Let's go ahead and let's see what we have here. All right. So what you're going to see is, hopefully you can still see my screen, right, Julian?
Yes, your screen is visible.
Okay, perfect. Right. And so what you're going to see here is I have a couple different things to demonstrate this migration pattern. So the first thing that you're gonna notice is I'll be using the command line terminal. That is my default UI. That's just old habits break hard. You'll also see VS Code, Visual Studio Code, and we'll demonstrate an extension that we're working on for analysis. I'll show MongoDB Compass, and then I'll show this specific application that we're running. That's this Node.js application. So let me just refresh this page. Right? And so what you're seeing right here is this is just my container management. This is all self-contained on my laptop. I develop locally deploy in the cloud, right? So just from a container management standpoint, I have everything. Starting the Oracle database, installing the utilities that I want, etc. Setting up ords, starting ords, checking the API, installing Mongo, setting up Mongo, connecting up to Mongo via Mongo shell, and then in the application, right, running my demo app, adding data, and then migrating some data, right? So what you're going to see here is we have a little application. This is a registration application that I wrote last year for Cloud World, and I'm going to use it again for AI World here as well, because we can just go ahead and we can just input, let's just say Tim Klein, and we'll just say Tim, and we'll just submit. And so now we have a new user in our database. So you'll notice here, this is how our users enter their information for our event, our conceptual event. And then we have a registrations page that shows all our users. And so our total count of registrations, the registrations broken down by our email domains, and then the individual listing of the users. So since I just added that user, Tim Klein, right, you'll notice that the oracle.com number has gone up. So I'm doing an aggregation pipeline inside of this location. And so that aggregation pipeline basically is, if we just go here to registrations, right? So what you're seeing here, so this is the the Node.js app, and you'll see that I have this aggregation pipeline that takes the email attribute, and then we split the email attribute to actually create an email domain. And so that was what actually creates this little table here where even though I don't have email domain in the document, I can actually use an aggregation pipeline to do some analytics, pull that out to tell me, right, an aggregate count of people, right, the email domains of people who have registered. So I can do this again. Let me just say, John, if I can type correctly, Smith. And if we say John at geocities.com, right, there we go. And now if we refresh this again, we'll see that John Smith's here at GeoCities, and we can see that it's broken down here as well, right? So additionally, what I have is this, sanity testing page. And the sanity testing page just is a demonstration to show that we're connecting to the MongoDB system and we're connecting to the Oracle system. So all the queries that are being done are all being done through MongoDB framework. So what you'll notice here in the application, you'll see that I require Mongoose. Mongoose is an ORM for documents. So this provides me connections to my MongoDB system. So I use an environmental variable to actually connect up to the Mongo system. So if we click on this environmental variable, right, I'll create MongoDB localhost, test, etc., to do all this access for that. And so this is all connecting up to the Mongo system via Mongoose. So I'm not using any OCI libraries. I'm not using SOTA-based libraries, Oracle thin drivers, etc. This is all just native Node application. So what you're seeing here is I have a current timestamp from the MongoDB system. And then you'll see here a current timestamp from Oracle. What I do as well is I just do a select sysdate from dual as part of the SQL operator that I showed here a little bit ago. But since I'm not connecting up to Oracle, I can't actually execute that SQL, right? MongoDB doesn't actually speak Oracle SQL, so it can't execute that SQL statement. And so it'll show that the MongoDB is connected, the Oracle is connected. I think for the Oracle connection status, I do like a simple like select one or something like that to show the Oracle connection status. And then it shows our current connection string. Right. And then lastly, here as well, we have just like a nice little map showing, geospatial workloads. This is all GeoJSON with inside of the document, right? So the bounding box is the globe at the moment, right? We'll make the bounding box kind of smaller if we wanted to do all that. And gentlemen that I just added by hand isn't there, right? This is our application. Yeah, right. And so now we will go into this little directory structure that I have here. And you'll notice that I have four subdirectories in this directory. I have 1.plan, 2.prepare, 3.execute, 4.validate. So the first thing that we do when we work with our customers is we ask them to run a very simple query, the DB server status query, to output that operator collector. So if we take a look at Mongo prepare, let me just go into the directory. And we take a look at that. It's a very simple query. So this is locally, I define an alias inside of the shell script, right? That's pointing to where I have Mongo shell installed on my laptop. I remove the pre-existing output, which is in /temp / ASkTom.json. And then I access Mongo shell to my local Mongo system, right? So this is all running inside of that container. And then I just evaluate this query where I do DB server status and I output that to the ASkTom JSON file. So let's just run this. And now we have this data. And if we do code temp it will bring up, there we go. All right, so now what you'll see in here, let me just get rid of this again. I'll do that again for everyone. All right, so there we go. And so now what you'll see here is inside of this JSON document, this ASkTom JSON document, there's a metrics array. Inside that array, you have operator counters. And so what you'll see here is we want to review these operator counters. And now if we can do this by hand, we can visually assess it, but it requires some degree of knowledge of the capabilities of the Oracle system. So what we're actually working on from a product perspective is a little utility, a VS Code extension. So if I access the VS Code extension, I say check MongoDB compatibility. I want to just take a look at this file. I'll take a look at this one. And so now what we'll see here, so this VS Code extension is a standalone extension for our Oracle State Explorer tool. So Oracle State Explorer has been extended to not only just do state assessments for your Oracle fleet and estate, it will also do it for your Mongo systems as well. But if you just need to do a very quick one-off kind of assessment of individual workloads, the VS Code tool provides that facility for you. So what you'll see here is it'll show us the number of compatible elements in your MongoDB instance, incompatible elements, and then we can review what's incompatible and things like that. So what this allows us to do is this then allows us to go back to our application team and say, oh, we might have to change is master, right? Now I know is master is a command that just doesn't really matter for a majority of workloads that I've encountered, but right, that's just from experience. But we can review this together with our customers. So this provides us a pretty good indication that things are going to go very smoothly for this migration. So now that we have done our analysis and we have a positive confirmation that we have a large degree of support in the Oracle API, we can now go into this section called prepare. And this Mongo prepare statement basically is just a little script, a little Python script that I use. And so what I do is I define various checks. So I define all the ORDS connections, the database connections I have, the Mongo connections, the Mongo DB API connections we have, the required privileges that I have, required roles that, right, to enable all this on-premise deployment of this. So if I go ahead and execute this Mongo prepare, I'm going to say all. So I have options to do, right? I have options in this little script to do various checks on words or Mongo or et cetera, things like that. So at the end of the day, it outputs this nice little connection report that I have that tests all those connections that I defined inside of the Python list. And so, right, it's showing that, hey, ORS is up and running because I'm using the Python library request just as a simple kind of request to that URL. There's the same thing for this IP address. I access this database. I check against all the roles and privileges that I specifically require. I make sure that the user schema is defined inside of the org schema. I make sure I have access to the MongoDB system, and then I make sure that I can actually write to the individual database, right? So everything here has passed. I have now another good proof positive and high degree of confidence that I can actually do the migration. So let's go ahead and do the actual data migration. So we'll clear this. And so I have this little tool, which is just do this again, which will just basically use Mongo, where to go? Mongo dump and then Mongo restore. It's in here somewhere. There it is. Right. So we'll go ahead and we'll loop through all the connections. We'll grab everything. And so again, this is a really good script if you have hundreds and hundreds of collections that you want to loop through and you want to remap from, say, the MongoDB database of test over to the Oracle user mat to do all that. And so we just do all that inside of this script. So let's take a look at how this data looks. So again, this is that tool Mongo Compass, and I have two connections defined here. So you notice here inside of Compass, let me just refresh this. I look at registrations, and you'll see that here's all the data that I have, right? Tim Klein's there, John Smith from GeoCities is there, right? So this is all inside of the MongoDB source system. So in order to move this data, I can just 22, migrate the data. And so what this will do is the script works in a decoupled fashion. So I can export the data, move that output over to the destination and then use the exact same script, just tell the script where the destination is, and I can import the data. So we'll do a combination of both at the moment. And so we'll do localhost, and I run my Mongo system on 23 456, and then this is on the map database. The script also supports authentication, SSL, all that good stuff. And so what I want to do is I want to export specifically the registrations collection. I mean, if I don't give it that collection specifically, it'll just loop through all collections that are found inside that database. So we'll just go ahead and put that there. And then, right, this tool supports a degree of parallelization. I don't really worry about it. We have 5 records temp, and we'll just call this ASkTom1, right? And so what you're seeing here is we just ran the export, and the export command was Mongo dump, the URI that specified the specific collection. We're compressing this in gzip-based compression into this directory /temp/ASkTom1, right? And so now what we want to do is we want to import this data. And so now we specify the Oracle API for MongoDB, right? So this is going to be your Oracle user password, very secure, if I say so myself. And then we specify the MongoDB enabled API schema, right? So this is where you do the orgs enabled schema, and you specify that individual user when you configure this. And we do temp ASkTom1. I think that's what it was. Yep. And so what you'll see here is that 5 documents were successfully restored inside of the Oracle database. And now if we go back over to this Oracle database, so here was the Mongo system. If I can zoom in on this for everyone. Here is the Mongo system. And now if I refresh the Oracle system, you'll notice that there's a registrations table. And in the registrations table, or registrations, the JSON collection table registrations, all the data is now present. And so we have a high degree of confidence, again, that our application was, or the data associated with the application was all migrated over. And so in order to check that, we'll go ahead, and this is another little thing that we've been experimenting with, where we validate the data. And so this validation utility that I have basically does just a count of documents, which is just can lead to false positives, right? Because you're not actually just counting the documents, you're actually counting what's inside the document. But then on top of that, I actually do a checksum of the entire collection and then a checksum of individual documents that are just accessed at random. So you'll see that I'm going to do all my checks here. And if I just pull up this report, right, you'll see here that affects the number of collections. I have 5 documents in the source Mongo system. I have 5 documents in the Oracle system. The checksum for the Mongo system was this. The checksum, right, the exact same data is present in the Oracle system. And then I just randomly access a document, just a super random query, right? So you can see we're doing JP here. We access that. We get to check some of that document, what's actually in the document, and we compare that with the document, the associated document inside the Oracle database as well. We have a high degree of confidence that we're ready to switch over. So now what we can do is we can kill our application, right? So our application is now done, right? So if I refresh this page, this should not, right? So the application is turned off. So now we'll restart the application. So we're going to run the registration demo app. And so this registration demo app uses a helper script to create that .environmental variable. So I'm going to do a local, number 2, local Oracle API. So I'll just type in localhost, my username. I think I typed in everything correctly, right? So here's my string. And so now if I go back to this test page here, you'll notice that on my test page, it still shows a MongoDB query of the timestamp for MongoDB because we're actually going through the Mongo API. We're using Mongoose. Mongoose is actually asking Mongo what time it is. And it's replying, our API is replying back, here you go, here's the time, don't worry about it. But then with Oracle, we can actually access this. The query that I do here is actually, let's bring this back up. The query that we do here is, here, best, go, there it is. All right, so the query that we're doing here is you can see that I actually do a, right, select sysdate from dual for getting the Oracle query. But again, I'm not using any Oracle libraries to accommodate that, to facilitate that. This is all via the Mongoose abstraction layer for all that. So the application is now cut over. And so now if we go back into our application, again, this web page was previously providing the data out in from Mongo as the data provider. And now if we refresh this page as well, it's the exact same application. All the data has been moved over. The support for Mongoose for the Node.js application is fully supported. So if we just refresh this page just to finish the drill, and then if we do the registrations page as well with the GeoJSON lat long pairs, those are all here as well, right? So these are all available. So with that, I'll push into the session recap as I think, how much time do we have, Julian?
Less than 2 minutes.
That's what I thought. All right, so just kind of a session recap here. So for the Oracle, for migrating from MongoDB to Oracle database via the MongoDB API, right? We have robust JSON capabilities. I can't emphasize this enough, right? So store, query, index documents natively inside of Oracle as a JSON document, right? Use JSON collection tables. These are fully ACID transactions, right? Full ACID transactions from the database. And then on top of that as well, as you're investigating this, we have a very groundbreaking bit of technology called JSON relational duality. So if you have pre-existing second normal form, third normal form implementations, and you want to provide that data to your JSON developers, you can use the JSON relational duality to actually accommodate that. The migration process is very straightforward, right? Plan, prepare, execute, and validate. Once you have that validation done and you're at that degree of comfort, switch over. Leverage the native Mongo tools as you can, if you can, for migrating your data. If you need to, your data migration requires a longer duration than what those tools can provide, leverage the Golden Gate for MongoDB. Again, it's free for 6 months to use. It's a container. We make kind of container management scripts available for all that. And then update your applications with no or minimal code changes. And then lastly, for more than just JSON, extending the workload to analytics, machine learning, spatial, etc. Um, Again, combining JSON with relational graph, spatial, and then you get the benefits of all of Oracle's performance, scalability, and enterprise level security by moving into this converged platform. And I think that's it, Julian.
Thank you very much, Matt. And we have one last question related to the registrations. Whenever there is a new registration, the aggregation pipeline gets called and gives the aggregation data. So the question is, if the collection is very big, is it a good way?
Well, there could be different approaches to do that, right? So if you're doing it and if you're doing it every time, you're kind of looping through the entire table every time. So you could make it more efficient by using, say, materialized views. You could make it more efficient by creating a virtual column and actually accessing the virtual column and indexing the virtual column. You can index the email attribute. There's a couple different approaches that you could do to make it way more efficient, right? The approach that you do on a table that has 5 records is substantially different from the approach that you do for a table that has 5 billion. But right, all these approaches are available to you regardless of the data size. But right, happy to talk about that. I will actually be at AI World. I have a migration booth. Feel free, feel free to shoot me an email for in-depth discussion on any of that stuff.
Thank you very much, Matt. Thank you very much, everyone, for participating. And I'll stop the recording now. Bye bye. Have a nice day.
Cheers.